Now we're going to look at some other aspects of sampling. And we're going to start with the idea of replacement. You can see this as sampling with replacement or sampling without replacement. So, what does it mean to do sampling with replacement? Well, it means that once a member of the population has been chosen for a sample, they go back into the general population and they could be chosen again. So it's kind of like catch and release for fishing. You catch a fish and you measure it and then you throw it back in the lake and it could potentially be caught again. This is as opposed to sampling without replacement, where a member of the population can be chosen only once. They cannot be chosen again. So once a person gets chosen in sampling without replacement, they get kind of set aside. They don't just get thrown back into the general population. And so they can't get chosen again for that sample. Now, these two ideas we're definitely going to touch on again later on in chapter 4 with probability. These kind of come into play there. But they do also come into play with sampling, especially if we look at various sample sizes. So, if we're looking at sampling with replacements for two different sample sizes, let's say first we're looking at a sample of 500 people, for instance. The first person we select has a 1 in 500 chance of being chosen, right? One person out of the 500. So sample, I guess not of 500. This is from a population of 500. So let me edit that. Population of 500. Okay. So the first person has a 1 in 500 chance of being selected from that population. So they're selected, they're measured with what regards to whatever we're looking at, and then they are replaced, thrown back into the general population. So there's still 500 people to choose from when we go to get our second person. So that second person also has a 1 in 500 chance of being selected. So it keeps things nice and equal. All right. And that's something we like when we're looking to do experiments without bias. Now, if we make that sample size smaller, or not the sample size, sorry guys, sampling from a population size that is smaller. Let's say we're sampling from a population of only 10 people. Okay, much, much smaller here. But we can see if we're using sampling with replacement, our first person has a 1 in 10 chance of being selected, one person out of the population of 10. And the second person also has a 1 in 10 chance because we get our first person, we measure their information, and we throw them back. We replace them. So the second person has that same chance. Now, this is going to be in contrast to our sampling without replacement. So you might be able to picture what's going to pop up here for our different sample sizes or population sizes. Let me correct those as well. Sample from a population of 500. Okay. So if we're taking a sample from a population of 500 people, again, our first person has a 1 in 500 chance of being chosen, one person out of the 500. But sampling without replacement, that first person does not go back into the general population. They cannot be chosen again. So now, when we're picking our second person, there's only 499 people left to choose from. So that second person has a 1 in 499 chance of being chosen. Now, if we look at the decimal values of these, they are not that different. 1 in 500 is 0.002. So that would be a 2% chance of being chosen. And then 1 in 499, that denominator is very, very close. So if we're rounding to the nearest percentage, this is actually still just a 2% chance. The decimal values 0.002004, etc., etc. So it still rounds to just 2% chance of being chosen. But where we kind of run into maybe some potentially sticky situations is if you have a smaller population size and we're sampling without replacement. So if we take samples from a population of only 10 people, our first person has a 1 in 10 chance of being selected, one person out of the 10. So that's a 10% chance of getting selected. Makes sense, hopefully. And then without replacement, we do not put that first person back into the population. They get set aside somehow. And so there's only 9 people left to choose from for the second person. They have a 1 in 9 chance of getting chosen. Okay, and so if we run the percentages on that, 1 in 10 is 10%, but 1 in 9 is about an 11% chance of getting chosen. So our second person has a little bit higher chances of being part of the sample. And you can imagine if we were to keep going with this and select, maybe 5, 6 people out of this tiny population to be part of the sample, their odds would start getting better and better that they were going to get chosen. So sometimes that can cause issues with certain experiments. It's just something to keep in mind. Okay, so that's the idea of replacements. And then we also want to look at the idea of different error types. And the first one of these is sampling error. This is a difference between the sample result and the overall population result. So you take your sample, you collect the information about them, and you get one, let's say, average for that sample. That could be different from the population because, well, we didn't ask the entire population. We're just looking at a little sample there. So maybe, you pick a sample of a certain number of people and find that their average height is 5'7". And for the full population, the actual result should have been 5'8". You just kind of picked a few people who happen to be shorter on the shorter side of the population. So this is actually totally normal and is to be expected to some degree. Because again, you're not asking everybody in the entire population, you're just looking at a sample. So we do expect some degree of error generally. Now, we expect some sampling error, but there's also non-sampling error. And in this type, data was incorrectly measured, recorded, or analyzed. This is preventable error, and we generally don't like this. So if the data was incorrectly measured, that could be due to having some defective equipment on the job. Okay, so maybe your measurement devices are not quite accurate enough. Okay, they need to be fixed or updated or something. This can be due to just simple human error, like if you're writing down the data by hand, like, oh, this guy is 5'6", this person is 5'9", etc. Maybe you wrote something down wrong and that threw off the results a little bit. Or you could have a biased experiment set up. And we're going to look more at experiment setups later in this chapter. but that could also be a factor in this. So this is non-sampling error, and these things are preventable and we would like to avoid them. So sampling error, this is really okay. I mean, it's to be expected to a certain degree that we have a sample that's a little bit different from the population. Non-sampling errors, we don't really want these. Again, those are correctable and we would like to avoid that type of error. So just some things to keep in mind, especially when you're reading through statistical results. All of these things, sampling types with replacement or without, and different types of error, they are all factors.